Hello everyone, welcome back to our YouTube channel. In today's video, I am going to solve today's Leetcode problem. Today's problem is find all anagram in a string. Okay, so first of all, let's understand the problem statement, and after that, we are going to solve the problem. So let's understand the problem. Given to a string s and p, return an array of all start indices of p's anagram in S. You may return the answer in any order. An anagram is a word or phrases formed by rearranging the letter of different words and phrases, typically using all the original letter exactly one. So basically, problem statement says that we have given two array. One array is denoted as s and not array, given to a string s and p. Okay, and the second is p. We have to check all the anagrams of p present in the s, and we have to return the starting indices from where the anagram should start it. Let's try to understand this problem in the whiteboard. Okay, so let's understand. So basically we have given two array. One array is s and another array is p. So in problem statement, so first of all, understand what is the anagram. So anagram is basically another string that contain the same character, only the order of the character is different. It means that if I can check the anagram of p, so anagram of p is like a c b, b a c, c b a, like that. It means that anagram is another string that contain all the character that present in the string p, but the rearrangement of the character is different. It means that if here b occur before c, but here b occur after c, like that. So anagram is rearrangement of character, but all the character are same. All character are same in anagram. So in this problem, it states that we have to check how many anagram of p present in the queue. Okay, and we have to return a vector, and such that the starting point of anagram. It means that if we have p a string given abc, to check where the anagram of p exists. So start with c, yeah, c is occur in the p as well, so include c. Check b is occur in the p as well, and a. So this is the first anagram we have found in the string s. So we have to return the starting point of this anagram. It means that if I write the indices, then 0 1, then a starting point 0. So in vector we have to we have to keep the starting point of every anagram. And the second anagram we have found is at these things BAC. BAC is also anagram, and in the starting point of the anagram is 2 3 4 5 6. The starting point in 6, and also we store it in the vector. Okay, so any another anagram exist? No, there is no any another anagram exist in the S of P. So we have to return the starting point of every anagram present in the string. So we have to return 0 and 6. So our answer is 0 6. Let's try to understand how to solve this problem. Okay, so the intuitive approach of solving this problem is, suppose in the string s, so in the string s we start with indices 0, start with 0, and for every indices first we take the length of both the strings. Suppose the length of S string is n and P string is k. Okay, in the string S, for every indices uh, take the substring of length k. Okay, so what I need to do, for every indices take a string temp that is denoted as the S dot substring starting with indices I and of length k. So in this string, if I take the a string of length k, here k is equal to 3, k is equal to 3, so the temp string will be cba, then compare this substring with the string p. If the all the character present in the string p and this temp string is equal, then we store the indices I in the answer array, vector answer array. After that we move this position at I is equal to 1, then again take the substring of length k, that is b a e, and again compare with these things. If the all the character of string p and this substring is equal, then take the indices I. If not, then move forward, then again comes here, again take the substring of length 3 and check a e b and check this substring with this string p. If all the characters are same, then store the ith index. Similarly, we iterate all the indices, and for every indices we take the substring of length k and check whether the two string are equal or not. If equal in the sense like every character in the string p and temp string occurs equal number of time. Okay, so this is the brute force approach that we should use in this question. But if you try to submit, then it will give you the TLE. So let's now try to understand some another approach that is little bit optimized than the approach we have already discussed, and that approach is based on the sliding window approach. Okay, so let's try to understand how we are able to solve the sliding window approach. So we take a map. In map, what I did, store the all character of the pattern we have to find in the S, in a gram of P in the S. So in the map we store the occurrence of every element. So in P, 1 occurs one time, B occurs one time, and C occurs one time. So this is the pattern we have to select from the string S, that if this pattern matches, then we have to take the starting indices of that pattern. So in sliding window, what I need to do, take two pointers, that is I pointer is initially 0 and j pointer is also start with 0. Okay, so let's write here. Okay, so let's I is also pointing to here and j is also pointing to here. So in sliding window, till the j not is equal to the end, then we run a loop. Then what happens? What is the length of sliding window? So length of sliding window is j minus I plus 1. At every iteration, the length of the sliding window is these things. So the length of sliding window has three conditions. Either it is less than equal to what are the length of p. Here length of p is 3. So length of the sliding window is either less than 3 or greater than 3 or equal to 3. Okay, if length of window is less than 3, then we have only one option to increase j. So if increase b doesn't have any other option, because if the length of the pattern p is not matches with the any window, then we have only one option to increase the length. If the length length of window hit the length of the pattern, then we have to check something like if the all character in this window is equal to whatever I store in the map. If equal, then store the indices I, okay, and if not equal, then increase. If we increase, then the sliding window size is greater than 3, then we have also maintain the sliding window of size 3 always. So for maintaining the sliding window of size 3, we remove from the starting index, that is I indices. So the basic approach of sliding window is that we have the length of the window has three options, either less than equal to 3, less than equal to 3 like size of the pattern, or greater than size of pattern, or equal to pattern. If the windows hit the size, then we do some calculation, okay, some calculation like we check the windows contain the every element that is stored in the map or not. If stored, then uh, push the starting indices, that is I in the answer array, and after that we move forward. Let's dry run this algorithm and check how it happens. So see what I do. I is starting with 0 indices and j is also starting with indices. So at this position the length of the sliding window is 1, because the length of the sliding window is j minus I plus 1. J is 0, I is 0 and 1. So 1 is less than 3. So what I do, we have only one option to increase j. Now j is here, j is at position 1. Now check the length of the window is 2, again less than 3, then again increase j. So j is now here. So at this point the length of the window is equal to 3. If j minus I plus 1 is equal to 3, okay, if this window hit, and also also put this j indices in the map array. Suppose take another map array and that take the indices of everything, okay. So c is 1 and b is also 1 and a is also 1. Before doing this calculation, we store all the element and whatever the frequency of that element in any map array. So for this s of I plus plus, we do these things. So c has one occurrence, b has also one, and a has also one. If hit the windows, then check the stored element and this element. If this is equal, it means that if take this map name as ms and this map name as mp, okay. If ms barabar mp, check c has occurrence 1, here also c has one occurrence, b has also one, b has also one, and a has also one, a has also one, okay. So both are equal. So in the answer array push the I, okay, and after that increase j plus plus. J is now here, and also after increasing also store it in the map array. So a has also occurrence 1. Then we have the size of the map array is 4. So in the third condition, j minus I plus 1 greater than 3. So we have to maintain the windows of length 3. So we remove element from the starting point. A starting point is here, I is still at 0 position and j is still here, okay. So what I need to do, subtract the occurrence of the element at ith position. Ith position has c character, then decrease the character of this element is 0, and if it becomes 0, then also erase from the map. So there are no existence of C character, and after that increase the I plus plus I plus plus, then we get the windows of size 3. Then again check if again check whether the MP if greater than 0, then first step is that if size of the window is greater than 3, then our first step is that occurrence decrease the occurrence of the map from the map at the ith character. Okay, and after that check if the occurrence is equal to 0 or not. Here the occurrence is 0, then erase from the map, ms dot erase that character from the map, and again hit the window size is equal to 3 to check at that position if ms barabar mp. If ms barabar mp, then store answer I in index in the answer array. Here this is not equal because b has occurrence 1, a has also occurrence 1, but here e has occurrence 1 and here c has occurrence 1, so the both are not equal. Then again increase the j plus plus, so again j plus plus become here j plus plus here. So now again the size of the window is become 4. So again do these things again and again till be reach at j is equal to n minus 1. So I hope you guys understand this problem statement. Let's try to understand the code that I will submit it. So let's see the code. So whatever the steps I repeated, I do that steps only. So this is the vector array that store the starting indices of every anagram and take the length of the S string and P string. Okay, and take the unordered map that store two map MP and MS. MP is the store the occurrence of character in P string and MS is the occurrence of character in the S string. So first store the occurrence of M character. Let's dry run for these cases. So in MP map, B store A is equal to 1, B is equal to 1, C is equal to 1. And for sliding window, take two pointer I and J and run the loop till J not is reach this point. Okay, and whatever the character occur from the S, put it in the MS unordered map. So starting indices is C. Okay, then check the window size. Window size will be j minus I plus 1. So window size is equal to 1, that is less than equal to 3. Here p size is equal to 3, less than 3, then increase j plus plus increases, and if hit the window, then check whether the two maps are equal or not. If equal, then put the indices in the answer array and increase j plus plus. And if the size is greater than 3, then first decrease the size at index I, then check if the size is equal to 0, then erase that character from the string, from the map, and increase the I plus plus. Again check whether the ms bar mp. If this happens, then push I in the vector array, then increase I plus plus, and at last we return the answer vector. Okay, I hope you guys understand the problem as well as the code. So if you try to submit this code, then you will get the correct answer. Let's try to submit and see. It will be submitted, and if I submit for all the test cases, then